we have another problem today. Okay, so I think there's like a fourth or so problem doing today. Just trying to get this behind me. And then we'll do some other things, maybe do some lectures. Okay. So this is from JEE paper 2, 2025. All right. This question is an interesting cyclic process. You get to do a lot of this in thermo. So this is a thermo problem. Okay. And it's a system is ideal gas, pretty good. It's monatomic gas. So all of these have information. It has n moles, which value is not given. So ideal gas means PV equals nRT, or if you want number of molecules, these moles, then you have Boltzmann's constant T. Physicists like this, chemists like that, and so you can see this problem is kind of in a chemistry language. All right, so ideal gas, and when you say monatomic gas, means each molecule has just one atom, so it's going to have just 3 degrees of freedom translation. Degrees of freedom is 3. So if you look at C molar specific heat, it will be, it's usually dF over 2 half RT. For each one of the moles is going to be 3 half RT. Constant volume and constant pressure molar specific heat, Cp is Cv plus R. That's the relationship. So this will give me 3 half R plus R, 5 half R. We don't know which one will need it, but this thinks you'll need it. And gamma is Cp over Cv, not T here. I don't know why I wrote on T. So it's 5 half R, 3 half R is 5/3. So these are things we are going to need, and you have to have this in your memory bank to start this problem. Okay. So it goes through a cycle. Cycle is described by going from here to here, here, and usually you do it in PV diagram. So you may be familiar with P and V like that. Okay, this is a familiar thing, but this is just V and T diagram. Same thing. Okay, similar. So what's also given is these volumes are given. So W is 64, volume in CC 64. This one is 125, and this is 250. And TW, let's call this T. TW is not given, but a condition is given for TW. So N or TW equals to 1 joule. So that's given. So this unit is given SI unit, but this is centimeter cube. So SI, this is not SI unit. Okay. And what are we supposed to find? Amount of heat absorbed in joules by the gas lung. So this is QXY, and the question is, so temperature goes up and volume goes up, then the pressure is actually constant. This one is pressure is constant, and this is adiabatic, and this is adiabat. Adiabat means Q equal to 0 and Q equal to 0 in this process. Okay, so it's like a takes in heat, this gives off heat. Unfortunately, they use the symbol W, and you may get confused over, is this W work? No, W just labeling this point in VT space. Okay. All right, so this is the question for us. Let's see, this happening constant pressure. So right away, we can start from here and see what do we need. QXY will be number of moles. I'm going at constant pressure. This is constant pressure. P is constant. dt. I need to integrate over this. Okay. Go from x to y. dx to dy. Now these guys are constant, and so just simply be n cp dy minus dx. Okay, so x and y are related by constant pressure. Then probably I can write this and remove one of these. So if you look at PV equals nRT, then if I bring V over here, so P is constant. So you can say that when I go on this process, this would mean this is constant, this is same. So Tx over Vx equals Ty over Vy. So let's get rid of Ty because x is next to W, so maybe write everything in terms of x. So Ty will just be Vy over Vx dx, and that's 250 over 125. I don't need to change units, same units cancel out, so 2 times dx. So this is 2 times dx, so n cp 2 times dx minus 1 dx. So this just ncp dx. That's pretty cool. Cp you already know is going to be 5 over 2 r. So let's write that down. N 5 over 2 r dx. So if I know dx, so we need to figure out 5 over 2 n r dx. All right, so this is adiabatic. what else you have to know is in adiabatic process, there's one more thing you should know in addition to these guys. In adiabatic process, such as W to X, the points along this process are connected by P V to the gamma equals to constant. Of course, you can write down P as nRT over V. So if you write this down like nRT V to the power gamma over V equal constant. So you can get rid of this guy, you can get rid of this guy. So TV to the power gamma minus 1 is also constant. So you could imagine trying to get rid of this Tx in terms of using this in terms of TW. All right, let's try to do that. So when you come to that point, you would say, okay, all right, I need to get rid of Tx. So using this, Tx Vx to the power gamma minus 1 must be Tw Vw to the power gamma minus 1. So bring it over here. So Tx is Tw Vw by Vx to the power gamma minus 1. Now it's the ratio, so I don't need to convert units. So what do we get? We get of course we get Tw. Vw is 64. Vx is 125. And gamma is 5/3. So 5/3 minus 1 is 2/3. Okay. So it's actually maybe because power is 3 down here, maybe see if we can do 4q and 5q 2/3. So these 3's will cancel that 1/3. So Tw 4/5. So let's carry on like that. Let's see how far it goes. It's going pretty far now. So 0.8 Tw. So over here, use over here, continue this calculation over here. We have a 5 nR times 4/5 Tw, just using this one instead of that guy. 5 cancels out. This becomes 2. So 2 nR Tw. Is that correct? I think a square got missed. So this is actually 16 over 25 Tw. So there's another factor of 4, another factor of 5. So another factor of 4 over 5. So this part is given, as you call, is 1 joules. This given is 1 joules. Actually, they really set it up problem quite well. So this becomes 8 over 5 joules. this is 1 joule. So 1.6 joules. So that's the answer. So 1.6 joules. That will be answer. Okay, that's it. Hope this helps you in some of the concepts here. So actually, as long as you know this much, you should be able to, get a strategy like this to solve it. There may be other ways to solve it, but this is, to me, appear to be pretty straightforward and direct. You start from what we have to know with an eye towards getting all the way back to here, okay? So the y things have to be written in terms of x things, and then x things have to be written in terms of w things. And the reason I want to go all the back there is because the data was given like this. All right, that's it. So I will see you in another video. Bye.